Now for this question, we're asked to write the three primary trig ratios for angle D. Now, one of the things is that we have to use the Pythagorean theorem because we have two sides of our right angle triangle and we're missing the third side. So to find the side length for side D, what we have to do is use Pythagorean theorem, which is c squared equals a squared plus b squared. So here, if you remember, the hypotenuse is opposite the right angle, so our hypotenuse is 15 feet, and D and the 12-foot side are our legs. So we can sub in for C equals 15 and B is equal to 12, and we're going to say that side A is our D. So we're going to simplify, square both sides, square everything. 15 squared is 225, 12 squared is 144, subtract 144 from both sides, and that is equals d squared equals 81. And we take the square root of both sides, and the square root of 81 is 9. So now we know the side length of side EF, and so now we can write our trig ratios based on angle D. Remember, we have to identify the adjacent, opposite, and hypotenuse for angle D. And the opposite side, there's our hypotenuse and our adjacent. So remember, sine of angle D is going to be the opposite side over divided by the hypotenuse. So the opposite side here, remember we found is D. Remember we found that D is 9. So this is going to be 9 over 15 because our hypotenuse is 15. And that reduces to lowest terms as 3 over 5. The next one, cosine, is for angle D is adjacent over hypotenuse. Our adjacent side is the 12-foot side, and the hypotenuse again is the 15-foot side. So that is equal to 12 over 15, which in lowest terms is 4 over 5. Tan for angle D is opposite over adjacent. Our opposite side is D, which is we found to be 9, over the adjacent side, which is 12. So this is 9 over 12, and in lowest terms it's 3 over 4.